Hi everyone, so our final skill of Unit 2 has just two problems, and it's implicit differentiation. This problem we're finding y prime, which is just our derivative, at the point 1, negative 2. So let's begin by finding our derivative. Starting on the left side, 3x squared is just 6x like normal, but this second expression involves an x function as well as a y, so we're going to be using the product rule and very carefully using implicit differentiation. So as always, we'll take the derivative of the first guy first, minus 8x, times leaving the second expression the same. Plus, now I'm going to copy down the first expression. And here's where I need to be careful with my implicit differentiation. So the derivative of y squared is going to be 2y y prime, or 2y dy dx. It's really the chain rule. I'm using the power rule to bring the 2 in front, and then I'm multiplying by the derivative. So let's finish. The derivative of y squared will be 2y y prime plus, now I'm moving on to this piece, the derivative of 6y cubed, that'll be 18y squared, you guessed it, y prime, equals, at the end the derivative will be 0. So our job is to get the derivative by itself, to get y prime all on its own. Well, notice now it's in two spots, here and here. So the only way I can isolate y prime, step 1, move all non-y prime terms to the other side. In this problem, that means this is going to move and this is going to move because they don't have a y prime. So in the same step, I went ahead and simplified, combining my negative 4 and my 2, for instance, and now all my non-y prime terms are on the other side. My next step is, so I'll factor out all my y primes now. Pulling that outside gives me, so y prime has been factored out, and I'm left with these two guys inside my parentheses. We're one step away. In our last step, we'll go ahead and divide both sides. Both sides by all this leftover junk. And magically, I'm left with y prime all by itself and some quotient on the right-hand side. Great. So we got the derivative all on its own, but the question didn't just say find the general derivative, y prime. It says find the derivative at that point. So let's plug in x to be 1 and y to be negative 2. Simplifying, let me check. 88 7 over 22. Okay, so last question of the unit. We're finding the derivative with respect to x, and again, notice that y is mixed in with the rest of the function, so we'll use implicit differentiation again. Why don't you try it this time and see if you get the right answer? Notice that we'll be using the product rule, so be very careful. The derivative of the first expression, hold the second guy the same, plus, this time I'm copying the first expression and taking the derivative of y. The derivative of a variable is usually 1, but since it's y and not x, we have to follow it up with a y prime. Okay, now let's take the derivative of the second term. So negative 15 x squared, copying down the y, minus 5x cubed the derivative of y is y prime equals 0. As we did in the previous question, we will now get all of our y primes on the same side, and any term not involving a y prime will move to the other side. I'm moving 6xy by subtracting it, and I'm moving negative 15x squared y by adding it to the other side. Next up, we're going to factor out our y squareds, or rather our y primes. And divide. We're left with y prime all by itself, meaning we've answered the question, which was to find the derivative. So you can label it y prime, or if you like, you can call it dy dx. They're both the same thing. And we're done.